Assalamualaikum and good day everyone. My name is Nur Hafizah binti Muhammad Sarif. I am from Faculty of Industrial Sciences and Technology, University Malaysia, Pahang. Welcome to the course Calculus is a Piece of Cake. Today, I'm going to explain an important mathematical concept in calculus, which is integration. Integration has many practical applications in real life. Integration can be applied to find the area between the curve. Integration can also estimate distance traveled by the object. By using integration, we can also calculate the total energy in the power consumption. Before we go any further, Before we go any further, let's see the definition of integration. Integration is antiderivative. In other words, finding an integral is the reverse process of finding a derivative. This is the notation of integration. This is a symbol of integration. The notation of integration derives from the stretch capital S for summation. And then this is the function of the fx is the function of fx is a function of x, and dx tells us that we are integrating with respect to x, where x is the variable of integration. The relationship between integration and differentiation is illustrated in figure 1. When we have y equal to function of x, when we differentiate y equal to function of x, we get dy dx is equal to f prime x. This is the process of differentiation. When we integrate the resulting differential, we will get the original equation, the original function. So integration is the process of anti-differentiation. Let's take a look at example 1. We want to evaluate the integral of 3x squared dx. Based on our knowledge of differentiation in chapter 2, the derivative of x cubed is 3x squared, or when we differentiate x cubed, we will get 3x squared. Since the integration is antiderivative, integral of 3x squared is equal to x cubed. That means when we integrate 3x squared dx, we will get x cubed. In the previous slide, we have seen that the integral of 3x squared is equal to x cubed. But we are not done yet. When we integrate any function, we need to add constant of integration in our solution. As I mentioned before, x is a variable of integration, so we are integrating 3x squared. We are integrating 3x squared with respect to x, and the answer is x cubed plus c. I will explain to you a little bit why we need to add plus C in our solution. Now I'm going to show you why we need to add constant in our solution of integration. When we differentiate x cubed plus 5, the answer is 3x squared. When we differentiate x cubed minus 2, the answer is also 3x squared. 5, if you notice, 5 and negative 2 is disappear during the differentiation process, because differentiate a constant will give a result is, because when we differentiate constant, the result is 0. However, when we integrate 3x squared, we will get x cubed. When we integrate 3x squared, we will get x cubed. Okay, sorry. Plus 5 and negative 2 is disappear during the integration process. Therefore, when we integrate 3x squared, we will get x cubed plus c, because c represents all possibilities of constants in the functions. So that's all for today. We are going to continue our next lesson later. Okay.